Okay, so this is my week 5 summary. Talking about what we did this week. This week we're talking about AC/DC current and AC and DC current. Sorry, but as you can see, we had chargers, force field, resistors. This is the stuff that was in for this week. But so I watched the videos that were done on the resistors. That was pretty actually very informative. I learned a lot from it. Let's see, talked about I really like the analogies that were given with the straws and the roads, and explaining how the resistance goes up the longer the channel is, or the pipe, or the straws. Like when you connect straws together, it's much harder to suck through the straw. Likewise with the road, as it gets wider, or if you add more straws, the resistance to be able to get something goes down, allowing much more flow, or yeah, I guess flow. And talked about the circuit simulations. I did those. Let's see, pull up some of those real fast here. Okay, so this is this was the 2-battery circuit, and the more batteries you put in line obviously increases the voltage, which increases the brightness of the bulb. I use the meter to check different stuff, but let's see. This was the 2 bulbs, with different resistance, and the one with the higher resistance did the opposite of what we thought it would do, because of the previous, the higher the resistance, typically, it would normally go dimmer, but because of the way this is done, in sequence with the lower resistance, this one actually gains more of the energy, or the current, or the power, so it makes it brighter. Let's see, the 3-bulb parallel circuit. None of these were affected by the other being turned on or off, because they're all getting their own 17.99 volts of power. So I think I showed that in this one. So they turn them off, they're still 17.99, still the same power. I've got a bunch of other ones, but I'm not going to go through them all right now. So anyway, this was actually pretty cool. I'm an electrician, so I can understand a lot of this stuff. At least you would hope so, anyway. Let's turn these ones down. Alright, you can just go back to this. Okay, so that was the circuit simulations. The physics classroom, I went through most of them, but for some reason it stopped working. So I had to go back through one that was like a cache copy or something, and some of the stuff's not working. So I wasn't able to get through all of these, but I got through most of them. The alternating current, I went and did some research on that as well. Like I said, I'm an electrician, so I work with AC, or I was an electrician, so I've worked with AC quite a bit. And electrical safety, believe me, I still got all my fingers and my toes. So, oh yeah, I did the other alternate homework or whatever, and I thought that was quite interesting. I actually went to the assignment number 2 on that as well, where it talked about the guy's pet bird and how he tried to save it on the high tension line, killed himself. That probably was pretty funny, but not funny, but different. I worked with the calculations on that to come up with the different watts and voltages. Found out there's a possibility of 1800 watts max in a 15 amp fuse with a 120 volt circuit. Of that, you have the 3 100 watt bulbs and 1100 watt iron, which would give you 1400 watts with a possibility of 18, so therefore the fan would only be minimum draws 400 watts. And I'm not really, maybe I was misunderstanding what they were talking about whenever he touched the area in the box, because if he touches the area in the box that's behind the circuit breaker, that's actually full power. So there's no way he's pulling his hand off of that. That's how you kill yourself. But supposedly for this simulation, we'll just say I'll follow the rules and say it was 8 to 15 mega amps or whatever, which is what it based on that chart. So so that was interesting. Then started looking at project number 2, trying to get my pieces ordered. I was trying to see if there's a place local that had some of this stuff, because I don't want to have to freaking buy a bunch of it off the internet. Wait for it. Discussion board this week. I did a neat resource on my neat resource talked about let's see, it was a motor. It was a, let's see here. Yeah, it's a homemade induction motor made out of a can.
Hey YouTube, I'm Nick from Nick282K, and this is my scrap box single phase induction motor.
And what I liked about this video,
this motor only took about 20 minutes to make. It has 2 coils, half a beer can, a small capacitor, and an AC power supply. The important part to making this work is that small capacitor. It makes a difference in phase between the current going through the 2 coils, causing a torque. In the pole of the motor that just has a coil, the current lags behind the voltage because of the inductance in the coil.
So that's why I like this video, because it has a lot of, it actually explains some of the physics and stuff like that. So I found it quite interesting. Plus I really would like to build one of these things. So David, if you're watching, maybe this is a good project. Anyway, not that I don't like your projects, I actually love your projects, but this is a cool project. So so that's that. And then let's see, so that was my neat thing, my neat resource for the week. And then also we're starting to I started working on some of my topics, my controversial topics. Oh, my observations for the simulations were with the grab bag, which I had a question. I don't know why that was possible, but I thought the dog and the hand would be able to conduct the electricity and allow the light to still light up, because I'm pretty sure that works, but in the simulation it did not work. I guess the only two that worked were the penny and the paper clip. So anyway, that is my week summary. Yeah, that's my week summary for this week. So I hope you enjoyed it, and I enjoyed my week, and I look forward to next week. Cheers.